Okay, so this is an introductory lecture to neurophysiology component of the neuroscience. So neurophysiology is basically how things work. So in this part of physiology or neuroscience, you'll be talking about how the brain works, how it operates, and how it speaks to the rest of the body, and how the rest of the body speaks to it. And basically, that's what we're going to talk about. In order for us to understand deeply the things that we're going to share, we are going to look at what our objectives are. So, we want to first of all look at the relevance of neurophysiology, and then we'll look at how it is organized, how is the system organized. Then we'll zero into the brain and look at neurons and glial cells, which are more of the major types of cells that are found within the brain, with the neurons being the active electrical reading type of neurons. And then we'll try to do a review of the neuronal signaling and neurotransmission that, of course, we did in the introductory component of physiology. That was your action potentials and everything. So we won't go into details, we just sort of review what you did. So in order for us to appreciate why we learn neuro things, neuroscience, neurophysiology, we have to look at the bigger picture and then sort of then come into the science of it. We see that as it is, we have a lot of brain diseases, a lot of diseases that can be linked to what is happening or not happening, or what is or what has gone wrong within the nervous system. First of all, we're looking at cerebrovascular episodes that are not only on the rise, but secondary to that, we have epilepsy, um, compressive mononeuropathies, and uh, diabetic polyneuropathies, shingles. All of these are diseases that within the setup of our culture, of Africa and of Zambia are actually on the rise. And so we want to see just what the science of this is, and then try to appreciate um, the physiology, and then understand the pathologies. Then we can go back, circle right back onto how to ensure that the physiology is reinstated. That's where you come in as clinicians. As a basic scientist, I am going to do as much as I can to look at the nitty-gritties of uh, the nervous system and how it works, so that as you look at it from the perspective of a clinician, you are looking at it as, how do I get back to the physiological state? All right. So, what is neurophysiology? In order to understand what neurophysiology is, everybody starts with what is called an exam. And this is where you look at what is happening to the brain, what is happening to the uh, two parts, which are the central nervous system, which is the brain and the spinal cord, and the peripheral, which are the sort of the pathways to the rest of the body and towards the central nervous system. And in order to fully understand, we have to learn what should be evaluated in these aspects: the brain, the central nervous system, peripheral nervous system, in order for us to really understand neurophysiology. So, there are a few things that I can point out. First of all, you're going to look at the sensory part, meaning how do you feel? How do you see? How does the soma, how does the flesh itself um, get the sensory stimulation? Okay, so how do you sense? What are the sensory functions? What is it that speaks to the environment before your brain can be alerted of what is going on? And then after looking at the sensory component, so this is what goes to the central nervous system, then goes up to the brain so that you can perceive it. We want to then now look at the reverse, which is how do action potentials move from the brain, which could be due to decision making or due to uh, something more autonomic. How do those move down and to the peripheral nervous system in order for you to carry out motor activities? So we're calling those motor functions. And in there, we're also going to learn about the various cranial nerve functions. Although this would be quite anatomical, it's something that we should appreciate. Not only that, we want to delve a little bit in the brain, the higher centers, and appreciate speech, language, mental status, falling in love. How do those things really happen in the brain? What are the connections? What makes you you? What makes your mind your mind? We talk about the limbic system. We talk about the hypothalamus itself. We talk about the role of various parts of the brain in what makes you physiologically you. So really, these are the things that speak to what neurophysiology is. So if we're looking at examining the neuro or taking a neurological exam, we look at what we should evaluate, and these are the sensory component, the motor component, the cranial nerve, and then we look at also the speech, how the person is speaking the language, and also the mental status, and all these will speak to the neurological state of an individual, and hence this is what frames our course neurophysiology. All right, so I'm gonna carry you through an exercise, and this is what I call a TPS. TPS is where you think, and then if you're with somebody watching this video in your room or wherever it is, or you're alone, you can pair with the other side of the brain. The part that is listening can pair with the other part that is not listening, and then you can share your ideas and then see what we can uh, come up with. So we have this scenario where a 79-year-old who has a history of hypertension, cigarette smoking, develops a weakness in the leg, and then he cannot stand unless he is assisted. So he is taken to this local hospital, and when you carry out your neurological exam, you note that the muscles on the left side or on the left arm also are weak, and the muscles of the left side of the face are also weak. So you also notice that he cannot smile symmetrically. So what is our question? Our question is number one, what aspects of the history that I have just presented to you do you think present the illness, the neuroanatomical information, since you've done quite a bit of anatomy so far? What things would help you make or form a good diagnosis? Okay. So you can pause the video and try to think about that. Next, what do you think the man is suffering from? Okay, pause, think, share before you move on. And then what part of the man's nervous system has suffered an injury? All right, so let's see if what was shared is, you know, what we could what we have here. So first of all, when we look about the bits and pieces of information there, we're talking about hypertension, the cigarette smoking, and the sudden occurrence of symptoms. And of course, if you said stroke, that was a good guess, or that was a good thinking pattern. And then what part of the man's nervous system has suffered this injury? We're talking about, okay, they have cortical white matter. Now we're going to learn about what white matter is and what gray matter is. Um, so it could be the fibers that actually bring in sensation or take in this individual. Um, so bring in, I beg your pardon, could be the fibers that actually take out uh, action potentials. So in this case, we are specifically looking at a component called the internal capsule. We think that maybe that's where this lesion could be, and then the descending cortical projection in the upper part of the brain may, be involved. But all in all, you look at what is it that you've examined, what is it that you can think about, and then you get back now to the neurophysiology and your neuroanatomy, and then form up the science. So like I said earlier, we have several diseases that we'll be looking at that include neurodegenerative diseases as well as psychiatric disorders. So you're going to have some time to actually look at this picture and see what it is that is uh, falling on which area, the degenerative or the psychiatric disorders. Okay, so having looked at the relevance and how that you can come back to the science in order to appreciate what you're looking at, let us now start from the very basics so that each of us is able to look at the question that we had and answer with ease what it is that we're talking about. So let's look at the nervous system organization. All right, so like I said, we have three main components: the brain, the spinal cord, and the nerves. So we have the brain and the spinal cord forming the central nervous system, and then we have the nerves that are coming to or going away from the central nervous system, being known as the peripheral nervous system. All in all, we see four main functions that the nervous system has, and this is voluntary movement, that is your ability to produce movement either with your hands, your legs, or any part of the body that can actually be taught to move by your brain. Perception, what is it that you are putting together or thinking about when you look at something, when you smell something, when you hear something? What is your brain saying? So that is perception. For example, some of you think blue is calming, whilst others think it's just irritating. They think brown is calming. Uh, Others perceive music as something that they could use to calm themselves and be able to study. Others perceive it as, being uh, an impediment in their progress. When they are studying, they want peace and quiet. So the way we perceive things, the way that we associate things that are in the external environment differs from individual to individual. All right. Homeostasis. Now, homeostasis is keeping things within physiological limits, and the central nervous system with the peripheral nervous system plays a key role in ensuring that your internal body temperature is kept okay, and many other systems are kept controlled: your heart rate, your breathing rate, your uh, electrolytes, your so many other things within your body, your sleep patterns. They're kept in a consistent and specific range. And then we have what I call abstract functions, but I think these are just higher center functions, such as the love language, the speaking, and the many other things that we could put up. So how we're going to do this, we are going to split our neurophysiology into these particular functions. We are, first of all, going to look at perception, actually. And perception starts with receiving the impulses, and those impulses turning our nervous system mechanism into action potentials that, of course, it can understand, and then them going all the way to the brain so that you can perceive. And after thinking and doing whatever it is that you want, then you voluntarily do something. So now we're going to look at voluntary movements. So we're going to look at the somatomotor system. The first one is going to be somatosensory, then somatomotor. After that, we're going to look at specific parts of the higher centers that have to deal with homeostasis and other components such as language, addiction, speaking, and as I've kept on saying, falling in love. Okay, so look forward to that. All right, so this slide is really just to break down what I said in the first slide. So the voluntary movements, when you are moving, this is volitional, meaning you have chosen, volunteered to do it, and it comes about, it comes with emotions. There's an emotional component tied to this movement. For example, anytime that you if you let me just break it down. If you sit next to somebody, look at them as they're listening to me speak. Whatever thing is on their face, that is volitional, that is a voluntary movement of their muscle. So if they are disgusted by what I'm saying or disgusted by the speed with which I am relaying these things, you will notice a shocked look, or maybe they're just not happy that you're in the room with them, then they will have another type of, muscle combination on their face. And whether they like it or not, they have volunteered to express that emotion to the external environment. So it comes with a key of emotions. Now, sometimes, yes, this can be a reflex, and we will talk about that. But we see that the control of motor neurons is really what uh, what is a function of the brainstem, and all these things you have been introduced to them in your neuroanatomy classes. That's the brainstem, the hindbrain, and also at reflex level we're talking about spinal cord involvement only. When we talk about perception, this is the conscious appreciation of the senses of what is coming to your system, and mostly controlled by cerebral cortex. Homeostasis, like I said, is keeping the body in physiological limits, and we're talking about oxygen control, blood pressure, temperature, life cycles, and so on and so forth. And it is a function of the brainstem, the spinal cord, the forebrain. Then last but not least, the higher functions, or what I called abstract functions in the previous slide, on the previous slide. So these are language, memory, learning, curiosity, interactions, and of course, most of this is really a function of the forebrain, but involves a large part of other brain components as well. For example, the amygdala, the limbic system, which moves across several parts of the brain, and we'll appreciate that as we go on with your both the neuroanatomy component and the neurophysiology component. The general organization goes without saying. We have the basic parts that are the spinal cord, the medulla, the pons, the cerebellum, midbrain, diacephallon, and all of these things that I'm saying are things that we're just introduced to you in your anatomy. And the peripheral nervous system, which has the sensory and the motor nerves. Right. Okay, so just to break it down, let's get back to what it is that I've said so far. So the nervous system is composed of the central nervous system and the peripheral nervous system. The central nervous system is the brain and the spinal cord, while the peripheral nervous system includes the sensory component, which brings action potentials to the nervous system, whilst the efferents, which are the motor, take away the action potentials to your motor uh, components so that activity may occur. And what we see is that the sensory component has two components. It's got the special components, where these are very specialized to specific parts of the body. For example, only your eyes can see, only your nose can smell. You cannot hear with your nose or see with your feet. So they are they've got specialized components or parts of your body that can detect various external stimulations, such as light for the eyes, chemical for the buds in your mouth, and sound for your ears, and so on and so forth. Okay. Then you have the generalized senses. These are parts of sensations that can be initiated from almost anywhere. You can feel touch on your fingers, on your toes, on your buttocks, or on your neck, on your face. So it's not specialized. As long as there's skin, the skin has specific receptors that can, uh, take that external stimulation and change it, transform it into action potentials. Your brain can figure out that you have been touched uh, on a particular part of your body. And it has the ability to determine, even though these are generalized sensations, the perception of where you've been touched can be detected by the brain. And why? Because you've got the map of your body on your brain. So when you're touched on your toe, it goes to the toe center. When you're touched on your finger, it goes to the finger center. And if you're touched on, yeah, whatever it is that you're thinking about, it goes to that part of the brain that represents that part of the body. So when we're talking about general senses, we are mainly talking about the somatic senses, but we also talk about the visceral, the ones that are coming from inside. That's the GIT, distension that you feel, the dull pain that can otherwise come from inside. We're talking about those things. The motor component is also divided into voluntary and involuntary. But voluntary somatic motor system is now where you volunteer and you move certain aspects of your body. And the involuntary component is also known as the autonomic responses, and we will also appreciate those as we go on. And under involuntary, I would end this slide by saying that you actually have the sympathetic nervous system and the parasympathetic nervous system, which are usually in a seesaw type of relationship. And depending on which component or depending on what's surrounding you or what the environment is like, one of these systems will take up the upper hand, and we will see how, why, and what kicks them in. All right, so before we go to the more neuroanatomical components, I'll pause my video right here and I would ask you to go through this section one more time before we look at the levels of central nervous system. All right.